propose new skill concept, and we will see the question based on the what we have learned in the previous video. So let's proceed our discussion. If you are new on my channel, so don't forget to subscribe, follow me, and Facebook share, and follow me on Instagram. So let's proceed our discussion. Now we have seen in our previous video, that is the shifting theorem, second shifting theorem. By using the second shifting theorem, we can easily find a Laplace transform of some given function or piecewise continuous function. So I am taking here as a Laplace transform. Find, write down the Laplace transform of gt is find where ft equal to et minus a t greater than a or 0 t less than. Now we know solution. What we can do, Laplace transform of ft is equal with f of s. Okay, then Laplace transform of gt is nothing but eas upon f of s. Here we have a function. Now we can easily see here f of t equal to et. Here e minus a is a constant. E minus a constant. Now we can find it. Now Laplace transform f of t what is equal to 1 plus s s minus 1. Okay, Laplace transform of t equal to s minus n. Here at will be, if that will be minus, so write down if at minus a, then that will be s plus a. Here a equal to 1, so that will be the minus. So now what is a here? Here you can easily see a is nothing but, so Laplace transform of gt what equal to that will es upon s minus 1. What is the a? So that is our discussion. Es upon f of s. Here es upon f of s minus 1. Okay, that is our change of scale property. We can easily find it. Now we are moving to the next concept question. So Laplace transform of gt equal to sin t plus pi by 3 where t greater than pi by 3 and 0 t less than pi by 3. Okay, so Laplace transform of gt what equal to, we can use the, it is 0 es upon f of s. Okay, now here f of t what, f of t equal to sin t, so Laplace transform of sin t what equal to s square plus 1. So Laplace transform here a equal to what, minus pi by 3. So you can easily understand it. So Laplace transform of gt what we can find it, e pi by 3 s upon s square plus 1. That is our Laplace transform. So that is okay. Now you can find the Laplace transform. Find the Laplace transform gt where t is given by t minus a cube t greater than a 0 t less than a. Here you can find it. Laplace transform of here ft you can easily see here at t cube. Okay, so you can find it. Now Laplace transform of ft is what, 3 factorial upon s 4. Okay, now here a equal to minus a, so Laplace transform of gt equal will give us e minus a s upon s 4. So here you can easily find it into e. So here e will be a, so 6. So that is our Laplace transform. So here that's the for second shifting theorem we have seen. Now we are going to extend our concept of change of scale property. Now write down the change of scale property. change of scale property. Write down the change of scale property. Change of scale property. So what is the change of scale property? If Laplace transform of t equal to f of s. So Laplace transform of f of at is equal to 1 by a f of s by. Can we prove it? Easily prove it. Let's Laplace transform of f infinity f of at e st dt. So let at equal to b. So a dt equal to db. dt equal to what? db upon a. So here we can easily find t equal to b by. So that change into infinity e. Then we are not talking about the limit. So if t equal to 0, b is 0, t infinity, b infinity, so the limit will not change. So s, instead of t you can write it b. So s by a into b. So f of b db, which is nothing but what? F of 1 by a f of s by a. That is f of b s by a. So that is our property. So you have proved it. Now find a Laplace transform. Find a Laplace transform sin 6t. Here can we find it? So ft is equal to what? Sin t. So Laplace transform of sin t what? 1 upon s square plus 1. So Laplace transform of sin 6t what? S square plus 1 minute. F of s 6. So 6 square 1 by 6. So after that calculation that give us s square plus 36. So that is our Laplace transform. So can you find a Laplace transform of 6 cos hyperbolic t 7. So what is Laplace transform of cos hyperbolic t equal to s upon s square plus 1. So here second Laplace transform of cos hyperbolic 60 what will give us s by 6 s square plus 6 square into 6 square 6 cancel. So 6s upon 6s square plus 36. So based on that you can find a Laplace transform by using change of scale property. That is easily done. Now I think I have to able to understand what is the change of scale property. Now you can easily find the Laplace transform of function. Now you can expand the Laplace transform. Now let's move another concept. Now we have done the basic concept of the Laplace transform. Now Laplace transform of a derivative. Write down the Laplace transform. Laplace transform of derivative. Let if ft is the x piecewise continuous function of exponential order as t tend to infinity. If f dash t is the derivative of function, then Laplace transform of f dash t is equal to s upon Laplace transform of f of t into f of 0. So that's what today. Now we will prove it. So we have seen the Laplace transform of derivative of a function. Now we can prove it. So here we can prove it. How to find a Laplace transform of a function. So let's prove our discussion. We have defined the Laplace transform of derivatives. So proof. So proof. We know Laplace transform of ft what 0 to infinity e s t upon f of t dt. Okay. So what we can do? So what we have? What we know? Laplace transform of f dash t is what will be 0 to infinity e s t upon f dash t into dt. Now by using the by part, that can be written as limit b tend to infinity 0 to b e s t upon f dash t dt. So after integration you can easily find it. That give us e s t after integration limit b tend to infinity f of t minus f of 0 plus s 0 to infinity a s t upon f of t dt. Now when we put this, that will change, will be 0, because what if we know that when that will be that term will be 0, because we know that ft is the function of exponential order. Okay, xt is the function of exponential order. That means then there exists for all m there exists a sigma e s t upon f of t is less than m. That means limit n tend to infinity f of t upon e s t give us 0. So that will changes b tend to infinity. So that's our proof. We have shown that f of t minus f of 0. So we have find a Laplace transform. So we of this. So Laplace transform of ft will be this. Can we find a Laplace transform of a function? So write down the question. I think you have understand how to. Now we find a Laplace transform. Find a Laplace transform of f dash t. We have what? Cos x. Okay, we have t. What is cos x? F of cos t left. Cos t. Find a f dash t. We have a Laplace transform. Now we have to find a Laplace transform. We know that is a derivative. Laplace transform f dash t what? You know, s upon f dash t. Laplace transform f dash t minus f of t. F of t, f of 0. What is the question I am checking here? We have let write down the question. Sin t equal to we have s square plus 1. So we have a given a Laplace transform sin t is equal to s minus 1. That question I have writing it down. So Laplace transform, we have to find a Laplace transform of ft. Okay, so ft what? Ft equal to 1 upon s square plus 1. Now above 0 what? It will be 0 square plus 1, that is 1. So Laplace transform of f dash t will be give s upon, okay, s square plus 1 minus 1. Okay, so that give us s 1 minus s square minus 1 upon s square plus 1. So after the calculation that will change, so minus s cube upon s square plus 1. So that is our Laplace transform of a function. Now we'll see the next some important question concept. So don't forget to share, subscribe, follow me on Facebook. Thank you. Bye.